Okay, let's get going. Hello, everybody. My name is Robert Hodges, and I'll be the presenter today at our talk on Fortress ClickHouse. We're going to be telling you how to secure your database and foil evildoers in 15 minutes or less. So before I get started, I just want to give you a little bit of housekeeping. If somebody can confirm that the audio is okay, just type it into the chat. That would be great to get that confirmation. You should be able to see my slides. So while you're confirming that, let me just let you know a few details about this talk. First of all, it is being recorded. So we will send you a mail message within about 24 hours that contains a link to the video of the talk as well as the slides. So you have those for your records. You don't have to frantically take notes. Another thing is that we do have time for questions on this. So if you'd like to, you can just put them into the webinar chat or into the question and answer box. Either one is fine. If it's a question that's relevant to what I'm talking about, I'll go ahead and cover it right there. Otherwise, we'll go ahead and take it at the end. Can I just get a confirmation that we have proper audio? Great, thank you, Kiara. Okay, off we go. So let's dig in. So just a little bit of marketing stuff. Of course, we're here to promote ourselves and Altinity. So here's some introductions so you know who you're talking to. So once again, my name is Robert Hodges, and I've been working on databases for 40 years. Kind of unbelievable now. I started with pre-relational databases, coming all the way up to modern analytic databases and distributed data. ClickHouse is the most recent one. I've been deeply involved in cloud native for the last 5 years or so, and my day job is I'm CEO of Altinity. So spend more time coding on spreadsheets, unfortunately, than writing real code for ClickHouse, but it's still fun. I want to highlight Vitaly Zakaznikov, who supplied a lot of the material for this talk. He's doing a blog article which will cover some of the issues that are covered in this talk and will appear shortly on the Altinity blog. But Vitaly has 15 or more years of experience with software and hardware test. He is the head of our QA department and really good on security, not least of all because one of the things we do in QA is we go ahead and automate the types of procedures that we'll be talking about in this talk and test them to make sure they really work. And then as far as Altinity, we are an enterprise provider for ClickHouse, which is a very popular data warehouse. I'll talk about that in just a minute. Among other things, we run a cloud for ClickHouse. Altinity.cloud was the first managed ClickHouse to appear in both Amazon as well as GCP. We run hundreds of ClickHouse clusters for our users. And we're also the authors of the Altinity Kubernetes operator for ClickHouse, so we're very deeply involved in cloud native computing. This is one of the most popular Kubernetes operators for data out on for databases on GitHub. And of course, we have a lot of involvement with other open source projects, not least of all ClickHouse, where over the years we've contributed many security features as well as tested them. So that's about us. Let's introduce our other star today. That's ClickHouse. So ClickHouse is what we call a real-time analytic database. And let me explain what that means. So it has the properties of a relational database like MySQL or Postgres. So for example, it understands SQL. We're not creating a new language based on JSON or something that you haven't heard of before. Another thing is that it runs pretty much anywhere. So like MySQL or Postgres, it will run on anything from literally from an Android phone. Somebody actually did that, all the way up to clusters on racked equipment that have hundreds of nodes. People also do that. And it runs great on everything in between, including cloud and Kubernetes. Finally, it's open source. So it's released under an Apache 2.0 license. And as a result, it can be used anywhere for any business purpose. Now, that's just the database part. But as far as the analytics, it has it is a column store. This is very common for analytic databases. It uses a shared nothing architecture, which means that there are chunks, there are processors with chunks of of storage attached. It is evolving rapidly to a separated storage compute model. It's very good at parallel and vectorized execution. By parallel, we mean being able to run multiple threads. Vectorized execution, we mean that we treat the data as effectively as vectors, which then get loaded onto the processor, and we can take advantage of vectorized CPU capabilities, for example, single instruction, multiple data that's present on Intel architectures. And it scales to many petabytes, like tens of petabytes. They're very, very large. There are clusters out there that have over 1,000 nodes. So it's a very powerful database, and it's become an extremely popular engine for delivering low latency analytics, especially for SaaS. So we won't talk too much more about ClickHouse's capabilities because the rest of this talk is discussing how to protect your data when it's living on ClickHouse. So to do that, one of the things that we have to discuss is what are the ClickHouse server attack surfaces? In other words, how can somebody what are the weak points that would allow somebody to come in and actually steal your data or otherwise compromise the information that you're storing there? So let's look at the model for a single ClickHouse server. And in our talk today, that will be our scope. There are, of course, larger issues or different issues as we begin to combine them in clusters. But for today, we'll look at just how to secure a single cluster and do that fairly quickly. So the types of threats that we see range from everything from unencrypted connection, unsecured default users, plain text passwords lying around, unencrypted data files, open file permissions, and exposing data and logs. Those are just a few of the ways that ClickHouse servers can be attacked. And so as we think about hardening a ClickHouse server, we need to have a way of detecting whether this is the case and then taking appropriate action, whether it be configuration or otherwise, to ensure that the holes are plugged. So let's start looking at those. So the first thing that we want to do is when our ClickHouse server comes up, think about what are the basic security checks that we're going to run to just make sure that the cluster is that the server is sane and that we're not going to have like immediately lose data. Let's jump in. So as we do this, what we want to do is we need to have a test server that we can play around with. And for the purposes of this talk, I'm using Docker. And the reason for this is that anybody can do it on a laptop. Basically, if you can run Docker on a laptop, you can repeat all the things that I'm showing you here. These commands here show you how to pull a ClickHouse server image. I'm picking a 23.3 LTS release. So that was released at the beginning of April. It is actually going to be the basis for the Altinity stable 23.3. These are long-term maintenance builds that we put out and which will be appearing shortly, but it's a good server to pick. Focus on stability there, has a lot of good bug fixes coming in. So what we're going to do is pull the container using Docker. That gets it on our host, be it a laptop or whatever. Then we're going to tag it. And this is just a trick that we use to, regardless of the name of the ClickHouse server, what version it is, we're just going to give it a name called My Fortress, and that will allow us to then run this and use a similar approach no matter which server version we're running or where we got it. And then the final part is running it on Docker. We're going to just go ahead and do a Docker run command, give it the standard name My Fortress so that we can issue commands to it very easily. And what we'll do here, these -v options show us mounting files in particular locations so that we can actually change the configuration of ClickHouse without having to go into the Docker container. So that's how we get started. These are commands that anybody here can repeat. And in fact, there are samples for this talk. Let me just go ahead and post them into the chat. And if you want to follow along, the samples that I'm using are bilateral out there. So let's dig in. Well, the first thing you do when you have a ClickHouse server is it's very helpful to just know where the server configuration files are located. So, and ClickHouse, by convention, stores all of its configuration files in etc ClickHouse server. And so that's a file. It's it's a directory on the file system. And then under it, when you come in and look at a fresh server, you will see a standard set of XML files, which contain basic server configuration as well as your default user, and then some directories, config.d and users.d. And these are very important directories because you can use these to put extensions in that change values. But because they live in if they live in these directories, and there's one other I'll show you in a minute, they are safe from upgrades. And this is an important thing to do when we're securing a server. We don't want to make changes in config.xml or users.xml because when an upgrade comes along, it will rewrite those files or can rewrite those files, and then we lose all our configuration and the server is insecure. So if you know these configuration, these server file locations, it's now easy to do some basic checks. And the first one we want to do is look for plain text passwords. So this is something that is kind of a heritage of the early development of ClickHouse. And if we just go in and go to etc ClickHouse server, we can just run egrep and look for password tokens or password tags. And this shows that we've got an unencrypted password or an empty password. So, and in fact, in users.xml, we see we have a password here that is empty, and it's for the default user. If you go in and look, you're going to see that it's the default user. There's also one in the config.xml file, which is the password for inner server queries. We're not going to go into the detail of how to do protect inner server communications today, but as you'll see, there's a talk coming up next week where we'll go deep on that topic. So let's now consider how to fix this. Well, first of all, if you're going to be defining users, there's a couple of very useful features you should be aware of if you're securing them. One is to know how to generate the password. And so this command shows you the example. If you want to take the word secret as your password, you just pass it through SHA-256 sum, and that's going to generate a hashed version that you can now use safely. Another cool feature that ClickHouse has is that it has network masks. This is kind of similar to the way that Postgres works, where we can basically restrict the connections that come into the server based on where they originate. If we put these two things together, we can now come up with a simple procedure or a simple configuration file that will secure that default ClickHouse user. And one thing that's really important to realize here is when you bring that server up, if you expose that port in a way that it can be seen outside of the Docker container or and including on another host, that means that you have a hole there and people can just log in and attack your server. So this configuration file uses those tips from the previous page, and it does three things. First, it's going to remove the old password. So this is a trick that we use to remove a blank password. It's a very important one because it allows us to make that tag disappear. It's not sufficient to comment it out because it already exists. And we're going to substitute it with another tag that uses a hexed password. We're going to put network masks in to limit the login to localhost. So these are the two tricks we saw on the previous page. And then one other thing we're going to do so that this is a flag that allows us to do SQL-based, role-based access control. So any further users no longer need to have, don't need to have this, we don't need to define these in the file system. We can actually use SQL commands. So if we go ahead and run this, and it's in the form of a script that's writing it into the users .d directory, it will basically lock the server down. Let's take a quick break here because one of the things that in the description of this talk was that I said you could do this in 15 minutes or less. And I'm not going to demo all of this, but what I'd like to do is provide a simple example of how to do this. And by the way, we do have a live question here, from Anastasia. Can we set the password with SHA-512? And let's just flip back here. That's a really good question. I think the tag is SHA-256, but if you have a look in the users.xml, it will tell you what the available tags are, and you can see whether that's supported. I normally use SHA-256. Anyway, thank you very much for that question. And let's go ahead and show you a quick demo of how we check this stuff out. So these are scripts that we have that are checked into a GitHub repo. I gave the link to this. You can go grab them. Let's just run one that checks for passwords. Pretty simple here. So it's basically execing into that container and just running that grep -r. Let's go ahead and run it. And boom, it just pulls this stuff out. And then if we want to actually go ahead and make this change, we can go ahead and run a script which will just secure the default user. We'll just run it. It was that fast. And in fact, let's see what's actually in there. It's pretty much exactly the command that we had before. Oops. So here you see the commands, and what this shows you, in fact, just for my own sanity, I do have the password shown in here so I can remember what it is. For the demo, of course, you wouldn't do that in a real case, but it's as simple as that. Once we've done this, this now has a password, and we can prove that without a great deal of ado by logging into the container and just checking to see whether we can get into the server using the default account. So we'll just do a docker exec -it. Let's give it the name Fortress. This is why we tag these or use these names, so it's easy to get into the containers. And we're going to use the bash script. Oops. Oh, just a second. Let me make sure this container is actually running. Okay, there's our container. Let's go ahead and do a docker exec -it, and again, go in. Oh, it's my Fortress. There we go. We're in, and now we'll go ahead and run the ClickHouse client command. Normally, if the account is unprotected, it looks like it is. It is. See, it's protected. It's asking us for a password. I'm going to go ahead and give it that password, and I'm in. But the point is, it blocked me, and really protecting the user, the default user, was as simple as that procedure that I showed you, and you can do it in seconds. So this is a similar thing applies to most of the other configuration that we're going to describe here. There are a couple exceptions which we'll touch on, but let's go ahead and put this away and look at more ways that we can secure the ClickHouse server. So the next thing that we want to do is, after we've secured the default user on ClickHouse, we want to go have a look at the network ports and shut down anything that isn't necessary. So let's have a look at, first of all, what are the available ports? So just as you want to know your configuration files, you want to know that ClickHouse has, ClickHouse has a wealth of protocols that it supports. Each of them is supported on a different port, typically. So for example, I'll just pick one. The MySQL client protocol allows you to log into ClickHouse as if you were a MySQL, using like the MySQL client tool or using a MySQL application. That listens on port 9004. Normally in a ClickHouse server, you don't want that port active. There are others that we will be focused on, like port 8443, which is to allow HTTP connections to ClickHouse. That is an encrypted port if it's correctly configured, and that's one that we want to have open. But we'd like to make sure that these other ports just get shut down. So let's have a look at how to do that. So what you can do is, if you're on the ClickHouse host, you can go ahead and run netstat and just look for all the all the ports that are open and have a listener. So with ClickHouse, this is since it's running inside a container, just to be totally clear, you would actually have to go and do an apt use apt commands, apt install, to go ahead and install netstat so that you could run this command. But of course, if you're running on a VM, it would there wouldn't be any issue. But what this shows us is there are some ports that we expect. So for example, the default port for the native TCP format, that's on 9000. This is unencrypted, but we'll take care of that in a minute. But we see 9004 and 9005. Those are the ports for MySQL and Postgres. Let's go ahead and shut those guys down. So again, very quick change here. We can go ahead and simply supply this XML that we show here. We just copy it into the conf.d directory and remove those tags. And this will require a restart. In fact, in general, with ClickHouse, anything that changes network configuration or storage configuration does require you to restart ClickHouse. And now that we're on authentication, by the way, I didn't see this question come up. A great question here. Is it possible to configure two-factor authentication? I'm going to take that answer at the end. We can discuss it further. The short answer for now is yes, it's possible, but you have to use something like LDAP. ClickHouse does not support it natively, and be very interested to learn more about your use case. That's and I can talk about some options here. So I'll leave this question open for now. Let's go ahead and then check that those ports really disappeared. This is something that's really important to do, which is that when you take these actions, make sure they really worked. So if we go back and run our netstat command and grep for listeners, we see those ports disappeared. Here's another cool check that you can do, a great trick, which is ClickHouse actually takes all the XML files and it gloms them together and creates a pre-processed file, which will not have comments. All the tags will be, if tags aren't used or they're overwritten, it will only show the overwritten values. And it's stored in this pre-processed config/config.xml. So that's a great place to go grep to make sure that things really disappeared. Let me show you one other trick. There is if you notice here, we wrote not to config.d, but instead to conf.d. This is an undocumented, actually an undocumented directory that is also supported by ClickHouse. We use this directory when we're dealing with containers. And the reason is that containers actually, in the container builds, they actually stick something in config.d. So we really don't own that directory. Docker wants to be able to write to it to be able to function correctly. So we use conf.d instead. So with this, you have three tricks for, some different tricks for being able to, supply the configuration and also make sure that things really disappeared. Let's now take care of networking. So application networking is obviously one of the major issues when you're talking about protecting a ClickHouse server. So what we want to do is, for this, is two things. Obviously, we'll have to set up the networking ports and configure them correctly. But the first thing before we do that is we will need to take care of getting certificates. And in this section, we'll just walk through how to create a private security certificate authority. So looking generally at how to manage certificates, there are three general ways that people can do this. One is that you could actually go to some sort of public CA like Let's Encrypt and get your and get your certificate generated for you. Another one is to have your own internal certificate authority. And this is sort of a middle ground. You could do it yourself, and I'm going to show you how to do that, the exact commands to do that. You could also use things like Vault or various commercial products which generate and track the certificates for you. The final thing you could do is a self-signed certificate. So, and just to be clear, what certificates do for anybody who's not familiar with them, certificates, the certificate authority has a root certificate, and it has a key that can be used to sign other certificates. And so your clients basically, as long as they can see the root certificate and they've accepted it, they can use that to confirm that your certificate authority actually signed this certificate and that, for example, ClickHouse is presenting, and therefore it's valid. Now, self-signed certificates are kind of a hack that you should never use. And there's two reasons for this. One is they're terribly insecure. And the other thing, the other reason why you shouldn't use them is it's just so easy to do a certificate, a proper certificate with an internal CA, that why wouldn't you do that? So let's go ahead and show you the commands to do that. So the first thing is you'll need OpenSSL, which is actually present on just about every on every Linux machine under creation, as well as Mac OS. So we'll run a couple of OpenSSL command. The first one generates a key, a private key, and then the second one is going to generate a certificate and self-sign it. So this is our root certificate. And these commands run almost instantly. The next thing that we're going to do is we're going to actually generate the certificate for the ClickHouse server. We don't use the root certificate because it's the one that allows us to show authority, and we share that cert with applications. But now we're going to go ahead and run these OpenSSL commands. They'll create a key for the server, and they're going to create a certificate, what's called a certificate signing request. And then we will feed that into the next command. And what it will do is this will sign it with our root certificate that we just generated. Finally, there's a step where ClickHouse can use Diffie-Hellman params for helping to pick ciphers and manage them. We can go ahead and generate them. This takes a really long time when you run it. So, for example, on the machine where I'm testing, it takes literally 15 minutes to generate these. So it's going to take a while, and we won't demo it today. But these are all the commands that you run once you've done this, and you can actually leave out the Diffie-Hellman params if you want, but you can basically be ready to go. Now, if you're doing this in a Docker container, as I am for this test, there's a couple extra steps that you need to know about. First of all is that I'm sharing the files from my underlying host. It is a machine that's actually a server that's actually running my closet, and I need to make sure the permissions are set correctly so that ClickHouse running inside Docker, when it sees these files, will see that they're permissions that it's allowed to read. So we go ahead and run this command, this chown command, to set the user and group permissions. The second thing is, because we generated a certificate which had a common name of Fortress, it's got to match the host name. So we're going to need to give Docker a little bit of help here and go ahead and add that as a name for our IP address. And you can see how I've edited Etsy hosts and added Fortress in. At this point, this certificate will run fine. In many cases, you won't need to do either of these steps. And then the final thing we want to do is we want to install the internal certificate that we generate and is used to help with signing. We go ahead and we install it in what's called the CA certificates directory, and this just makes it available to any application that uses the baked-in SSL libraries on Linux, and that includes ClickHouse Client. So once you've done this, actually, the ClickHouse client will now be able to connect, and it will see an SSL connection. It will select the ciphers and or it can select the ciphers as soon as we've done the configuration. So we've got everything set up in terms of certificates. What we need to do now is the second part of protecting the application connections, which is to actually supply the configuration so that ClickHouse will encrypt them correctly. So let's dig into how that works. Well, it's just a long XML file. It's really pretty simple. I'm going to go through this file and cover some of the highlights, but basically what we're going to do is supply another configuration file. We're going to stick it in conf.d, and the first thing we're going to do is disable the unencrypted ports to talk to ClickHouse, and we're going to enable the encrypted ports. So you see us removing ports and then adding them. So again, this remove trick is really important. Here we say remove equals true. I previously said remove equals 1. Either one will work. It will take this. It will go ahead and take the ports away. So far so good. The more interesting part is there's what's called an OpenSSL section in the configuration. And that OpenSSL section allows us to define the encryption that is used on server connections. This is anytime we're listening on a port. And here's the standard settings. So we have the certificate file, the server.crt, that's our cert, our private key. We give those locations. A few things that I want to highlight in these settings, because they will save you from a lot of trouble, is where it says load default CA file, certificate authority file, we say false, because we're giving it, if we said true, it would go out and just read it from the from the certificate store that's available on the host. We don't want to do that. We want to use the certificate that we've given it. And the specific CA config. The next thing is verification mode relaxed. This sounds like a bad thing, but actually it isn't. What it means, there's another setting, strict, which you can use. And what relaxed means is that we will allow the client to connect, and it will of course have to form a proper encrypted connection using TLS with the server, and then we'll allow it to connect. If we say strict, not only does it have to be able to handle the ciphers and do the normal negotiation of the encryption, but the client must also supply a certificate, so that it must, and that certificate must be signed by a CA that the ClickHouse server recognizes. So if we say strict, that will mean that any client, no matter what it is, will actually have to supply a client certificate as well. So you can do that. It's actually pretty easy to set up. But the problem is that some clients, you don't necessarily want to do that. It means that you have to distribute a lot of certificates out to your clients. Other things to notice, we're disabling protocols. So I'm using the word TLS explicitly or with purpose. We want to disable SSL v2 and v3. These are ancient protocols not supported by pretty much anywhere. So we're not going to accept clients that can only talk to them. We might disable TLS 1.1. We might disable TLS 1.2. This allows us to force clients to behave. And then finally, this reject certificate handler, this is the default, but this says, hey, like if we're having a problem with certificates, we're gonna drop them and not continue. So you can also use this to handle self-signed certificates, but as I mentioned, that's not a good idea. On the client side, and this will be used whenever ClickHouse is using the standard SSL library, which is boring SSL. There are similar settings going outbound, which tells it, hey, where's my, for example, where's my root certificate that I use for authorization, so on and so forth, protocols that I turn off, and things like that. So this is a second part that you want to have, and it's particularly, you must configure this correctly if you're doing communication between servers, or you're using Zookeeper or Keeper, ClickHouse Keeper, and they have encrypted connections. This must be correctly configured as well. So with that, once you've supplied this this configuration and restarted your server, at that point you'll be able to see that ClickHouse client will just be able to connect using a secure connection. And in fact, if you try to do it without a secure connection, it'll just bounce you back out again. So So setting up, in summary, setting up TLS on ClickHouse is pretty simple. There's absolutely no reason not to do your own internal CA, even for testing. It just takes, if you leave out the Diffie-Hellman params, it takes seconds to run and to configure it. Let's talk a little bit about, we've talked about in-flight encryption. Let's talk a little bit about at-rest encryption. So in-flight means that we're protecting data or encrypting data as it moves across the network. At-rest means that we're encrypting it as it's in storage. And for this, we don't have simple examples because many of these things are need configuration. But there's a couple options to do this on ClickHouse right now that are very commonly used. The first is just to go hog wild and encrypt the file system. So you can use Linux Unified Key Setup. That's a pretty standard approach, particularly for people who are running these things at home. If you're running a VM inside Amazon or Google or some other cloud, the cloud block storage typically, in fact, almost always has out-of-the-box storage encryption, so you can just use it when you create volumes. EBS does this, of course. And then if you're running in Kubernetes and you don't want to futz around with, which you might be because you don't want to futz around with the cloud interfaces, this is really easy in Kubernetes. The block storage provider typically has, for example, this is an example of encrypted true option that is on the storage class that's used for Amazon EBS, and with that, your volumes are encrypted wherever they live. So this is super easy to do, and as a result, it's very commonly used. There's another approach, which is that ClickHouse itself can encrypt data that's written to it, and we do this using what's called a storage policy. A storage policy allows us to, there's sort of a hierarchy of definitions. We have a policy called encrypted. It defines a volume called encrypted volume. It defines a disk, which is the encrypted disk, which then points to an actual location on the file system. It seems a little complicated, but the point is you have a policy which you can now use when you create tables, and that explicitly tells ClickHouse, hey, write this to that disk, and it's going to be encrypted along the way. So here's a slightly readable or somewhat difficult to read example of what these storage policies actually look like. They're kind of long, so I squished it down to make it work on the page, but here's your disks. So for example, you have the encrypted disk, which then points to disk 1, which is an actual location. You have the policy encrypted, which has a volume defined as the encrypted called encrypted volume. It has a disk inside it called encrypted disk. That's an actual mount point we can write to. So these files, once they're set up, you don't have to touch them, they just work. And here's how you would create a table that writes to one of these encrypted volumes. You simply, when you create your table, you set the storage policy to give the name of the policy you want to use. In this case, it means the data would be encrypted. One question that people commonly ask is, how much does this cost? Because we all know that encryption takes CPU time. It's not terribly expensive. The numbers I've seen, and we have these out on in our knowledge base. One of the tests that I saw, and I haven't tested it personally, but one of the tests I saw, it showed about a 20% hit on performance if you're going encrypted. So if that's something that's important to you, it's not a big deal, and it's very easy to add in this way. The nice thing about this approach, it will work anywhere. So moving off the storage of your data, one other interesting question to look at is how to protect logs. And this is something that we don't always think about, but ClickHouse maintains a query log, and there's also server logs, which contain information, and particularly the text of queries that ClickHouse is running. Let's have a look at how we might protect that. So for example, here's a log entry for a query that we're running, and where we're using the decrypt function. So there are functions in ClickHouse that do AES encryption, and we might not want to have the keys that we're using be shown. So for example, we'd pass them into as a string from the query, or we might have information, we might have other information inside this select, which would reveal things like credit card numbers, or it would reveal usernames, data that you want to keep private or you don't want to have exposed. And in this particular log entry, we can actually see that instead of seeing arguments, they've actually been pulled out and just replaced by question marks. And what this means then is if this log gets exported out to something like Datadog, for example, or LogZ, or Prometheus, or well, not Prometheus, that's not such a good example, but anything that you're using to manage logs, this data will not be in the log and therefore it can't be exposed. How do we do that? Basically through query masking rules. So this is a feature that actually Altinity put in back in 2019 that allows you to write a series, as many rules as you like. They are basically a regular expression, which gives a match. And then when it gets a match, it just goes ahead and does a replacement. So what this is doing is it's finding if you can read this regular expression, which no doubt some people on the call find this totally easy to read, it's looking, what you want to do is look for a match, and then the first argument, or the first matched value, you want to replace it with those 3 question marks. So you can write as many of these as you want. Obviously, you have to tweak them yourself to get them to work, but you can pretty much hide anything you want. So at this point, we're kind of running toward the end. I'd like to talk about some final notes here and things to come, and then we can take questions, including this 2FA question. So parting tips on host level security. So this is something that didn't seem to fit in super well. You can put it in the first checks, but just some things about protecting the host and your single server. First of all, ClickHouse does a really pretty good job of other than having the unprotected default user, it overall does a really good job of protecting data. The file permissions are good. It runs as ClickHouse runs as the ClickHouse user. So you may use root to start and stop it, but for example, if you're running on a VM or a racked host, but it doesn't use root privileges when it's actually running. That's great. And then it's also very good about directory protections. 3 main areas where you want to be concerned about are Etsy ClickHouse server. Those are the credentials. We've talked about that. Credentials and actually configuration information. We've talked about that a lot, but the credentials are the things you want to protect. Varlib ClickHouse, that's your data, is living under there. And nowadays, if people are using role-based access control, which are SQL commands, it's also going to contain the definitions for your users, and of course there'll be passwords there. And then finally, the varlog ClickHouse servers where your logs are. Again, you can't get in there without root access, but this is a place where queries can be exposed. But generally speaking, the protections are good on all 3 of these, and you don't have to worry about people just waltzing in and seeing the data. A final thing that you may want to think about, and in fact you should think about for your host, is, well, how can people get to this host? And so for example, if you're running in Amazon inside a VPC, you may have load balancers and that give public access either to other VPCs in your account or even to the public internet. It's really important to think about what those load balancers are doing, and are they giving access to your server from a place that you don't control, and where that might give a root in for evildoers. And so in general, you also want to make the server networks, wherever possible, non-routable to outsiders. So for example, you keep your applications within the VPC, route directly to them, but just have the servers not even be routable. You've got to go into that VPC, into a jump host to even see it. And so the broader network protection, you want to think about this when you're protecting your host. And with that, here's some further areas which we'll cover in later talks. Cluster security. So this is such a big topic that I didn't include it in this talk, because there's just so many ways that this can play out. There are fairly basic protections of allowing, for example, ClickHouse to do a distributed query, which means that one ClickHouse server is going to go and log into other servers. We want to make sure it has the right account. We want to make sure that it is that's properly encrypted, so on and so forth. So that's a topic to look into more deeply. A second thing is hardening ClickHouse in cloud native environments. So when you move to Kubernetes, you get different issues. You have the same threat surface, of course, for the database that you have outside of Kubernetes, but Kubernetes introduces some new concerns, and we actually have a hardening guide that covers this for our Kubernetes operator, and we will be extending it because there are many additional issues, like, for example, when you're managing databases in Kubernetes, you don't want to give them too many privileges inside Kubernetes, because a mistake there could cause Kubernetes to stop functioning. There are other topics like FIPS compatible ClickHouse. This is often a very common requirement for FedRAMP and other high security environments. And then, of course, there's a whole question of protecting backups. If you want to steal data, backups are actually one of the great ways to go there. And so we'll have additional presentations and blog articles on each of these. One of the things I should point out, though, is if you're interested in this topic, we're going to be going deep on both FIPS compatible ClickHouse, as well as general topics on ClickHouse cluster security, like how to make Zookeeper work in high security environments. You can join us on Tuesday the 20th and at 10 a.m. Pacific, and we'll be talking with folks who are working at Cisco to go through these to go through the process of bringing up ClickHouse on FedRAMP. So this is something you're welcome to attend, and you'll learn more about all of these topics. More background information, of course, the ClickHouse docs, they have piles of information. We have security documentation at Altinity. We will be extending it. The Altinity blog has regular articles on security. I mentioned the operator hardening guide. That's something we've developed for the ClickHouse operator. And then the sample code that you've seen here is available out at this link on the Altinity GitHub, ClickHouse SQL examples. And you can go there and just, if you're want to see the code and examples, just go ahead and grab them. So with this, we're done with the talk, and I think it's a good time to talk about this question. Please feel free to add more questions, but there's this question about how to configure 2FA or two-factor authentication, and that's a great one because out of the box, ClickHouse doesn't support it, but it does integrate. So, and by that I mean that, just left to its own devices, ClickHouse will really, you have a couple of options. One is you can use a, like a login and a password, sort of the time-honored way of protecting of establishing identity, which is, hey, you got to prove you got the password for a particular login. The other thing that you can do, which is kind of interesting and less well known, is you can use mutual TLS. So, this is pretty easy to do. For example, for service accounts, you can not only require, we talked about the fact that strict authentication will require both sides to present valid signed certificates. You can also construct accounts that will have to present a specific certificate to be able to log in. So that's also possible to do. As far as 2FA, I think the way to get that is you would need to integrate with something like an LDAP server that itself had 2FA authentication. ClickHouse can call to LDAP to actually do the authentication, but I think you'd have to configure something on top to make that work. This is an area where there's definitely some interest, and if you need this, feel free to contact us because we're very interested in this topic ourselves, and how to enable this for people. Another option for for authentication is to use Kerberos. That's also supported by ClickHouse, and is something that we did some of the implementation on that some time back. So I hope that helps. If describe your options. It's so for example, there isn't ClickHouse, to my knowledge, does not have a way of doing OAuth, which is it's something that commonly comes up, but I have no doubt that that will be added at some point in the future, if it's not being added already. Okay. Any other questions? By the way, Vitaly Zakaznikov, you are on the call. Welcome, and thank you so much for all the information that you provided, particularly around the configuration of networking.
Thanks, Robert. It was
Great.
It was a pleasure to work on it.
Yeah, and much of this information flows out the specific procedures. I will just share one final piece of information with you, is that it is really important to go find documented procedures and develop automated tests for them when you're checking. When you are setting this stuff up. We do this ourselves, and because the thing about security procedures, and network configuration is a great example, if you set it up perfectly, it works. If you don't set it up perfectly, or you violate some assumption, it does not work. Not only that, it won't tell you why. So it'll just say, hey, this account didn't work, or I can't connect. That's a typical answer that applications will get if, for example, an application attempts to make an unencrypted connection with a TLS encrypted server port. So you'll get very little information. It'll just say can't connect, and you won't be able to see the error. So definitely, finding the procedures, setting it up carefully, testing it, and using an automatic test so that you can confirm that the procedure is working exactly as you expect, and then using that as your procedure to configure from then on out. That's the way to go. And that's how we approach when we're helping people with the security. The procedures that we develop are based on our tests. Okay, well, I don't see further questions. So with that, I would like to thank everyone who attended. Vitaly, once again, thank you for the great information in this talk. It made it a lot easier. And we hope to see you at a future talk. If you have further questions about security or any aspect of operating ClickHouse or analytic stacks, please feel free to contact us at altinity.com. You can also find there's various ways to get hold of us, but we'd love to talk to you, and have a great day. Thank you.